Hello, my name is Alejandro Mesa. I'm here recording a demo for visual databases at Columbia at Spring 2012. So basically, what I did is I wrote an OCR program to do some text detection. The way the program works is that it uses over 1,000 images of characters from 3 different fonts, and the fonts are Arial, Sans, and Trebuchet MS. Um, in this demo, we're going to use this image that you see on the screen. Um, we're going to run it through the program and see what the results are. So the way the program works is that it uses k-nearest neighbors or support vector machines as the machine learning algorithms. It uses six different feature extraction types, such as binary blob, global features such as the area, the perimeter, density, things like that. Zoning divides the character into zones of 8 by 8 pixels, and it calculates the density on those. Um, Global underscore zoning is a combination of the global and the zoning features. BDD, which stands for background directional distribution, it's a calculation value of the direction of the foreground pixels based on the background. And zoning underscore BDD is a combination of the zoning features in BDD. And all, it just allows you to run the program with all the features at a time. And the dash I is basically just the path to the image. So when I run the program using KNN with all of the features and a simple image, for the binary blob features, you can see that if you go down pretty much the text, every character except for an uppercase O here. Now you can see there's a count of 5 out of 10, and for lowercase also a count of 5. So it's about a 50-50 split, but everything else seems to be pretty accurate, but you can see there's still a lot of second and third predictions. So it's somewhat accurate, but we'll see in a moment that there's more accurate feature extraction methodologies. So for global features, it's actually quite the opposite. If you go down, it'll be pretty difficult to recognize what the original image said based on these characters. And you can see there's high count also for second and third predictions. So that just goes to show that global features is actually not that good for feature set. If you go to zoning features, you can see that everything down here got predicted well for the most part, except for the I. This one should be an uppercase I, and there's actually out of 10 elements, 4 are actually lowercase I, 3 are uppercase I, and then another 3 are actually lowercase L. So it's still, you still be able to figure out from here what the original image said. And there's still a little bit of a couple of stragglers on the second and third prediction counts, but so far it seems quite accurate. If we try to combine global zoning features, you can see that it's still pretty difficult to read what the original image said. So adding zoning features to global actually didn't really do much, and it's still a high count of second and third prediction values here. For the next one, if we use background directional distribution features, you can see this is actually quite accurate. Every character in here got detected correctly, and there's not that many second predictions and no third predictions. So this actually shows that BDD is actually a pretty good feature set for character recognition. And the last one is combining zoning and BDD and see what that does. And um, again, every character in here, if you read up and down, get recognized correctly. But there's actually a couple more second predictions. So adding zoning to BDD actually decreased the accuracy instead of increasing that. So BDD alone seems to be, compared to the values up here, seems to be a little bit better than the combination of zoning and BDD. Now, another way to run the program is using support vector machines. So again, I run the same image using support vector machines with all of the extraction features. Now, if you look at the output looks quite different, and the reason for that is that the OpenCV implementation of support vector machine doesn't really give you a count; it just gives you a prediction. But it's still an okay way to compare versus KNN to see how good it predicted. So if you use binary blob features, if you see, if you go all the way down, at some point in here we had an uppercase O. You can see that with SVM it actually predicted, everything seems to be right on. So not too bad for binary blobs. For global features, it detected a couple more things, but it's still pretty bad to trying to figure out what the original image said. You can actually maybe figure out that this probably says Python. Interpreter will be kind of hard to get out of here. Um, and everything else is just all over the place. So still global features for SVM is still not good. For zoning features, um, it pretty much detected everything correctly. So again, not too bad. Um, Using SVMs. And if we go to global and zoning, still all over the place with SVMs. We saw the same thing with KNN, so it just goes to show that global features is just not a good feature set. If you look at BDD, you could pretty much read everything that the original image said. So it's pretty good recognition. And jumping to the last one is zoning and background directional distribution. Once again, you can pretty much figure out what the original image said based on the characters. So in the end, you can see that we got a little bit better accuracy using support vector machines over KNN using the same feature set. So um, that concludes that SVM is actually better. And that's it for the demo. Thank you very much.